Okay, so let's talk about broadcasting, which is another concept of NumPy arrays. And so far, I think it is also one of the most important concepts that we need to study. So before we dive into that, let's recall universal functions. So in order to, whenever we wanted to add a constant to the array, we saw that the application, the function, and the operation is applied to all the values across the array. So let's visualize what happens when we're multiplying a constant to a NumPy array. So we have seen that the operation is applied to all the values, but what happens is that the constant is converted into a NumPy array. And this particular operation is called broadcasting. We have broadcasted the value of the constant into an array, and then we have applied an operation between these two arrays. So in reality, although it looks like we're adding or multiplying a constant, but what we're actually doing is that we're multiplying two different arrays. So let's look at computation on arrays. Now we have seen that even when we're talking about constants, we're actually talking about arrays. So let's see the operations on different arrays to understand the concept of broadcasting a bit better. So we have two arrays. We have A and B, and we're going to add them, and the answer is quite simple. But the important thing we need to see over here is that the size of both the arrays is equal. Okay, now remember that. So this figure visualizes what broadcasting does. If we have one constant and we have an array of 3 values, the 5 value will be broadcasted to meet, or you can say to meet the size of that array, and then we can apply the operation. And the same thing is done in all different operations. So the second figure tells us that if we have a 2D array and we have a 1D array and we want to add it, so what would happen that the 1D array will be broadcasted across 2 more rows, and it will be converted into a 2D array, and then the operation will be performed. Now the third figure is rather interesting. What we're seeing over here is that broadcasting is done on both arrays. Okay, so let's look at them. We have a 3x1 array of 0, 1, 2, and we're going to add them, and we're going to see what happens over here is that the difference of dimensions is met by broadcasting. So the overall concept of broadcasting is something like, in order to meet the dimension requirements of addition and subtraction, because the size should be equal, the dimensions should be same, that's how the operation shall be performed. So what NumPy does is that it creates copies of the same values across different dimensions in order to meet those two requirements whenever the operations are performed. So let's look at the rules of broadcasting. The number one rule is that if two arrays differ in their number of dimensions, the shape of the one with the fewer dimensions is padded with ones on its leading left side. Okay, so if we're talking about two arrays and one of them has dimensions that is less, then it will be padded by ones on its leading left side. The second rule is that if the shape of the two arrays do not match in any dimension, the array with shape equal to 1 in that dimension is stretched to match the other shape. You see that rule 2 is applied to the constants, okay, and number 1 rule is applied to the you can say the arrays of two different dimensions. Okay, and the third rule is that if in any dimension the sizes disagree and neither is equal to 1, an error is raised. Okay, so the third rule tells us that only if that the dimension sizes disagree and neither is equal to 1. So okay, so in this case the error will be raised, and this is the only case for that. Lastly, let's talk about comparison functions. Comparison functions are just like comparison operators we saw before. If we want to check that x is less than 3 and x is an array, we're going to compare each and every value of x, and that we're going to compare it with 3, and the result will be true, false, like any other comparison operator. And this goes on and on. It is quite simple, and this is the comparison operation for NumPy arrays.